Faraday laws. Faraday put forward two laws regarding the quantity of electricity passed through the electrolytes and the amount of substance deposited or liberated at electrodes. These laws are known as fundamental laws of electrodynamics, also called quantitative relationships of electrolytes. These are also applicable to all electrolytes at all temperatures, pressures, and other conditions. Which laws are applicable at all temperatures to all electrolytes at any previous Faraday laws? First law. Here they said two laws. Underline. First law. The amount of substance deposited or liberated or dissolved at the electrode during the electrolysis is directly proportional to the quantity of electricity passing through the electrolyte. It is defined as M directly proportional to Q. First law is where M is equals to weight of a substance in grams, Q is equal to quantity of electricity in coulombs, Q is equal to C into T. Here C is current of strength in amperes, time in seconds, M directly proportional to here Q means C into T. So C into T, or M is equals to E is constant, C into T. Then where E is constant, known as electrochemical equivalent and is characteristic of the substance deposited. If Q is equals to 1 coulomb, then E is equals to M. Okay. Then E is equals to M. Correct. E. Electrochemical equivalent means E. It may be defined as the amount of a substance deposited by passing 1 coulomb of electricity through the electrolyte. Once again, electrochemical equivalent may be defined as the amount of substance deposited by passing 1 coulomb of electricity through the electrolyte. It is also defined as the amount of substance deposited by passing a current strength 1 ampere for 1 second. The units of electrochemical equivalent are gram, ampere per second, or gram per coulomb. The SI units of E means electrochemical equivalent are kg, coulomb, 1 inverse. First law completed. Now second law. The same quantity of electricity passed to different electrolytes, and the weight of the substance deposited at the respective electrodes are in the ratio of their chemical equivalence. The second law is mathematically expressed as first law small e, second law capital E is equivalent weight of the substance. Here E is equal to electrochemical equivalent the substance. If the same quantity of an electricity is passed through 2 or more different electrolytes, the second law is applied. Once again, the same quantity of electricity is passed through 2 or more different electrolytes, the second law is applied. Let the weight of a substance A be AA and the equivalent weight of AB EA. Weight equivalent weight as it is for B, weight of the substance VB and equivalent weight is VB. Then according to the second law, once again revision. According to second law, W weight means directly proportional to capital WA by WB is equal to EA by EB, or WA by EA is equals to WB by EB. M directly proportional to C, C directly proportional to T. First law and W directly proportional to E. Second law on the combining the two Faraday's law, we can get this one. M directly proportional to capital E into C into T, or M is equals to 1 by F into capital E into C into T. or m is equals to small m is equals to capital M into C into T by N into capital F. What is meant by capital F? Capital M is the atomic weight of the element and F is the proportionality constant called Faraday. Faraday is defined as the quantity of electricity required to deposit or to dissolve 1 gram equivalent weight of a substance. The total charge present on 1 mole of electrons is known as Faraday. Both Coulomb and Faraday are the units of a quantity of electricity. Coulomb represents a smaller quantity and Faraday represents a larger quantity of electricity. 1 Faraday is equal to charge of 1 mole of electrons, charge of a 6.023 into 10 power 23 electrons. And Faraday is usually taken as 96,500 coulomb. Units of a Faraday are coulomb per mole. Electrochemical equivalent is equals to equivalent by 96,500 or is equal to atomic weight by into 96,500. Here the N is equal to valency of the element. Faraday law of the electrolysis are useful for the determination of the amounts of the substance deposited, the quantity of electricity, the number of electrons passing through the electrolyte, equivalent weights, atomic weights, and valency. Next video we will see sums on this topic. Like, share, and subscribe.